Hi, Madam Mazrin. I'm Justin. Today, Johnny and me will be going to present about the static and dynamic project.
Hi madam, I'm Johnny and I'm doing the question 7-70. For this question, we are told to draw the share and moment diagram. At first, we need to identify the support region. By drawing the free body diagram, we found that we need to find the value of AY and BY. From the calculation, we can calculate that the BY was equal to 950 Newton while Ay was equal to 450 Newton. Next, we divide the beam into several segments. For the segment before 800 Newton, we found that the moment at point s equal to 0 was equal to 0 Newton meter. For the moment at point s equal to 1, the moment was 450 Newton meter. This is the moment diagram for the segment before 800 Newton. Next, let us look at the segment which include 800 Newton. Assume the summation Fy equal to 0. We found that the shear force was 450 Newton. The moment that we found that the moment at point s equal to 0 was 0 Newton meter, while the moment at point s equal to 1 was 450 Newton meter. These are the shear and moment diagrams which for the segment which include 800 Newton. Next, let us look at the segment before 1200 Newton meter. Based on the free body diagram of the segment before 100 and 2000 Newton meter, the shear force that we found was negative 350 Newton. For the moment at point s equal to 1, the moment that we found was 450 Newton meter. For the moment at point s equal to 2, the moment that we found was 100 Newton meter. And these are the shear and moment diagram for the segment which was before 1200 Newton meter. For the segment which include 1200 Newton meter, we found that the shear force was equal to negative 350 Newton, while the moment at point x equal to 2 was 1300 Newton meter. This is because the moment of 1200 Newton meter was included, and it caused the moment equation to become negative 350x plus 2000. These are the shear and moment diagrams for the segment which include 1200 Newton meter. Then, for the segment before 600 Newton, we found that the equation of the moment was 2000 minus 350x. For the moment at point s equal to 2, the moment was 1300 Newton meter, while at point s equal to 3, its moment was 950 Newton meter. This is its moment diagram. For the segment which includes 600 Newton, we found that the moment at point s equal to 2 was 1300 Newton meter, and at point s equal to 3, the moment was 950 Newton meter. These are the shear and moment diagram for the segment which includes 600 Newton. For the segment at bit Y, we found that the moment at S equal to 3 was equal to 950 Newton meter, while the moment at point S equal to 4, this moment was equal to 0 Newton meter. These are the shear and moment diagram which is at the BY.
Thank you, Johnny, for presenting the previous question. Now I'm going to present about the problem 771. So the first step I did is I identify the support system first. So at point A, the support system is identified to be a pin. So we know that there will be two unknowns, which is AX and AY. And then at point B, the support system is roller. So there will only one unknown at point B, which is BY. Secondly, I draw out the flexibility diagram with A component and also B component. And then I identify AX, AY and also BY by using the resultant force equal to 0 and also the moment equal to 0. So I let the resultant force of Fy equal to 0, then I managed to get a formula which AY equal to 1200 minus BY. And then for Fs, there's no other force acting along S axis, so we can directly make sure that AS is equal to 0 Newton. And then the second step is that I did the resultant moment at point A is equal to 0. So I managed to find that the BY is equal to 600 Newton, and then I substitute the BY into the AY formula, then I managed to get AY equal to 600 Newton. Thirdly, I cut the beam into 4 different parts before and after each of the 600 Newton force. So the first cutting is done before the 600 Newton force, and then I use again the resultant force of Y equal to 0. Then I managed to come out with the shear force, which is equal to 600 Newton at the cutting point. And then I use the resultant moment of C equal to 0. So I managed to come out with the moment at the cutting point equal to 600 x. So I substitute the x with 0 and also 1. Then I managed to get the moment equal to 0 when x equal to 0 and moment when equal to 600 when x equal to 1. So the second cutting is made after the 600 Newton. So again, I use the resultant force of Y equal to 0. Then I managed to form that the shear force at the cutting point is equal to 0 Newton, and again I apply the moment at cutting point equal to 0. So I managed to find out that the moment is equal to 600 when S equal to 1. Let's move on. So the third cutting point is met before another 600 Newton force. So again, apply the resultant force of Y equal to 0. I managed to find that the shear force at cutting point is equal to 0 Newton when x equal to 3. So with the resultant moment equal to 0, I managed to find that the moment at the cutting point is equal to 600 Newton meter when x equal to 3. Furthermore, the last cutting point is met after the second 600 Newton. With the formula resultant force of Y equal to 0, I managed to find that the shear force at cutting point is equal to negative 600 Newton from x equal to 3 and x equal to 4. And then with the formula of resultant moment equal to 0, I managed to find that when x equal to 3, the resultant the moment should be 600 Newton, and when s equal to 4, the moment should be 0 Newton. As a result, from all the information gathered, I managed to come out with the shear diagram and also the moment diagram. That's all from us. Thank you for listening.